Hello children, welcome back. So in this video I'll be discussing about force and the laws of motion. The first law of motion, which is known as the law of inertia, and the concept of momentum. So when we say force, in your lower class you have got what is the meaning of force. Force is something which of kind of physical quantity which helps us to bring about some kind of changes. What are the different kind of changes? It helps us to slow down a body, it helps us to increase the speed of a body, it helps us to stop motion in a body, or it helps us to start motion in a body, or it helps us to change the direction in a body, or it helps us to change the shape and size of a body. So if all these changes can be brought about, we say that force is being applied. Now in class 9 you have the beginning with the concept of balanced and unbalanced force. Suppose we have a car here. Okay, these are two similar cars. Now suppose this car is pushing this car and both are applying force on each other. Now when both are applying force on each other, suppose the car, they are not moving. Okay, so when they are not moving, we can say that both are applying equal force in opposite direction. Under such a condition, it is called balanced force. Now suppose one car increases its force and pushes the other car in the backward direction. Under that condition, what will happen? We can say, now if this is the case, what we can say that the yellow car is applying more force and therefore it is pushing the green car in the backward direction. So therefore the yellow car is applying more force compared to the green car, so the movement is taking place in the direction of the greater force. So this is the example of unbalanced force. So after balanced and unbalanced force, now we will be discussing about the law of inertia. But before we discuss about the law of inertia, let me show you some experiments, so it will help us to understand better. We take a jar here or a glass, and there's an experiment which many of you must have done. We take a cardboard, and on this cardboard we place a 10 rupee coin. Now what I do, with a sudden jerk, I pull the cardboard away. So what happens to the coin? The coin falls into the jar. So I'll be discussing why these are happening. So you just remember the experiment. Another experiment you see here. Suppose I take a mug of water and I stir it. Stir it. The water goes into a state of motion. Now when I will remove stirring, the water will still be moving in this container before coming to stop. It will move or it will circle out for few minutes. ये घूमते रहेगा थोड़ा देर के लिए, फिर जाके रुकेगा. Another experiment, suppose there is a vehicle and suppose this is a luggage. On top of the vehicle there is the luggage, and suppose the luggage is not tied on top of the van, and the van comes and it suddenly stops. So what happens to the luggage above the van? It falls. So what we do, we have seen that on top of vehicles generally luggage is tied. Then we have another experiment, that is, I have taken a card and I have sprinkled powder on it. Let's say that this is a doormat and this is dust or dirt on the doormat. Now generally what we do to remove the dust, we tap it or hit it against a wall. Now suppose when I will hit it, what do you see? That the dust simply falls off. Now why it is happening, all these things I'll be discussing one by one. So let us see the theory related with all this, and after learning the theory, then we'll see to the explanation. So coming to the concept of inertia. So what do we mean by inertia? Inertia is the property of a body. It's a basic property of the body or tendency of a body to continue in its original state. If it is at rest, it will remain at rest. If it is in a state of motion, it will remain in motion. So that is the concept of inertia. Inertia word comes from the word inert. Let me focus the page a bit. Okay. So this inertia, it is the tendency of a body to remain in its original state of either motion or rest. So inertia comes from the word inert. Inert means a tendency to remain in original state. So जो change होना नहीं चाहता उसी को inert body बोला जाता है. Now when we talk about inertia, it is of two types. One is inertia of rest, another one is your inertia of motion. So how can we define inertia of rest? It is the property of a body which is at rest to remain in the state of rest until applied upon by external unbalanced force. So if a body is at rest, suppose this rubber, I am keeping this rubber here. For how long this rubber will remain here? The rubber will remain here as long as we are not applying some kind of force to move it from its original motion. Forever it can stay here if no outside force acts on it. So that is the concept of inertia of rest, the tendency to remain in a state of rest when any body is at rest. Second is inertia of motion. It is the property of a body which is in motion to remain in a state of motion until applied upon by an external unbalanced force. For example, suppose this is a roller and I roll it. It will roll for a distance and then it will stop. Or suppose we take a ball and we roll it, it will roll for a distance and it will stop. Now why it stops we know, because there is frictional force. If the friction is less, the ball will roll for a longer distance. If we can create a condition where there is absolutely no friction like in space, so if we can leave a body in a frictionless surface, then the body will keep on moving and it will not stop until you are not applying some kind of force to stop it. So that is also a kind of inertia. So we have two types of inertia, inertia of rest and inertia of motion. In some books you will also find a third kind of inertia, that is inertia of direction. That means very simple, any body going in a particular direction will continue to remain in that direction until some kind of force is not applied to change the direction. It will have a tendency to move in that direction. Actually that can be brought under the inertia of motion as well. So from this we get Newton's first law of motion or law of inertia. Actually combining these two we will get the first law, the statement of which is any body which is in a state of rest or motion will continue to be in that state. What state? The state of rest or motion until applied by an external unbalanced force. It has to be an unbalanced force. Okay. So what are the different applications? The first application is seat belts. You have seen गाड़ी में seat belt रहता है, क्यों रहता है? So when we are putting out the seat belt, कभी जोर से brake लगा दिया, so suppose suddenly the brakes are applied, we will have a tendency to fall in the forward direction. So why? Because when the brakes are applied, the lower part of our body comes to rest along with the car, but the upper part of our body will have a tendency to remain in a state of motion due to inertia, and then it will fall in the forward direction. So to prevent that, we have the seat belts. Luggage is tied. Just a little while ago I gave you this example of a vehicle and the load on top. What happened? The vehicle was moving, and along with the vehicle the load was also moving. Now when the vehicle suddenly stopped, the vehicle came to rest, but the load continued to remain in a state of motion due to inertia, and then it fell in the forward direction. इसलिए कोई भी सामान हम लोग ऊपर में ले जाते हैं, लगेज, तो उसको हम लोग बांध देते हैं. We tie that. So luggage is tied on top of vehicles. Then falling backward on a sudden start. Suppose you are standing inside a vehicle and suddenly the vehicle starts and you tend to fall in the backward direction. So then what will happen? Why? Because when the vehicle suddenly starts, your lower portion of your body, your legs comes into a state of motion, but your body tends to remain in a state of rest because it was at rest. So क्या होता है कि आपका बॉडी का निचले वाला जो पार्ट होता है वो आगे चला जाता है एंड योर बॉडी वहीं का वहीं रहना चाहता है, तो ऐसा लगता है कि वो पीछे की तरफ आ गया. सो इट विल हैव अ टेंडेंसी टू फॉल इन द बैकवर्ड डायरेक्शन. देन हिटिंग अ कारपेट विद अ स्टिक. सो यू हैव सीन, हम लोग जब कारपेट, जैसे कि ये एक्सपेरिमेंट मैंने समझाया था पाउडर लेके, सपोज देयर इज़ अ कारपेट एंड देयर इज़ डस्ट ऑन इट. when you will hit it with a stick, suddenly then what happens, the carpet is coming into motion, लेकिन यहाँ पे जो dust होता है, that dust will tend to remain in a state of rest due to inertia. तो carpet हट जाता है and the dust will fall off. Similarly, hitting a doormat on a wall, similar reason. यहाँ पे क्या होता है, suppose this is the doormat and this is the wall, you are hitting the doormat on the wall. So along with the doormat, the dust particles in the doormat is also in a state of what? Motion. When the doormat will come and hit the wall, it will suddenly come to rest. But the dust inside the doormat will have a tendency to remain in motion. That's why what happens, the dust particles will simply fall out of your doormat. So that is one example. Then the example of this coin and the card that I showed you before. So what happens, we are suddenly pulling away. Initially the coin and the card both are at rest, but when you are suddenly removing the card, then the coin tends to stay in a state of rest and it falls into the cup or the glass and the card moves away. So same way the water, when you are moving water in a glass, swirling water, जब चाय बनाते हैं, so क्या होता है, चाय रुक नहीं जाता, थोड़ा देर वो घूमते रहता है. Why? When we are swirling it, the tea is in motion. The moment we stop moving it, the tea will tend to remain in a state of motion due to inertia and slowly it will come to rest. So all these are different examples that we can cite. There are more examples which you can cite. So that's the concept of inertia. Next concept in this video we'll be discussing is about momentum. So what is the theoretical definition of momentum? So it is a physical quantity. Generally books में समझाया जाता है, it is a product of mass and velocity. Okay, but that is a numerical definition. Practical definition is what? It is a physical quantity which helps us to estimate the amount of impact a body will have when it collides against another body. So suppose there are two bodies. Suppose this is a truck, okay, and suppose there is a car. Fine. So now suppose the truck and the car comes and collides against each other. So and both are moving at the same speed, which will experience more damage. Obviously the car. Why? Because you know the truck is bigger and it has got greater mass. So when two bodies they collide, what will be the impact? What will be the amount of impact that we get from the concept of momentum? What will be the amount of impact? So if the mass is more, just the example that I gave you, if the mass is more, the momentum will be more. Is that clear? And suppose you are standing against a bike or you are leaning against a car which is not in motion, you will not experience any force. But if the same vehicle, if the same bike comes at a greater speed and hits you, obviously the impact will be more. So that means what? Impact not only depends on mass, it also depends on velocity. Okay, so we can say that momentum is a physical quantity which is dependent on the product of mass and velocity of the body. So there's just the numerical part. Momentum can be written as mass into velocity. So velocity is vector. This arrow over the variable indicates vector quantity. So momentum is also a vector. So momentum is m into v. So momentum is a vector quantity. So what will be the SI unit? That P is equal to m into v. So m का SI unit होता है kg, velocity का meter per second. So kg meter per second. And the CGS unit, CGS means the lower unit of SI. Mass SI unit is gram and velocity is centimeter per second. So combining we get gram centimeter per second. So that is the concept of momentum. So I gave you two examples. First example I gave you a small vehicle and a big vehicle both coming at same speed and hitting each other. Where the impact will be more? On the small vehicle, because the other vehicle, the bigger vehicle, the mass is more, so the impact depends on mass. Second example I gave you, you are standing against a stationary bike and the same bike comes and hits you with a certain velocity. So in case of the bike coming and hitting you, the impact will be more. So the impact also depends on velocity. So that is momentum, a physical quantity which depends on mass and velocity. So these concept of momentum and inertia, all these things will be required later on when we'll try to understand Newton's application of Newton's second law of motion. कोई example होता है, there we'll try to apply this concept of momentum and inertia. So up to here, I hope the concept of inertia and momentum is clear to you. In the next video, we'll be discussing about Newton's second law of motion and the equation F is equal to ma and the application of that. Thank you.